When humans first began launching spacecraft, the first spacecraft set out to explore the solar system. Venus, our closest planet, was the next to be explored. In 1962, a neighbor. Mars followed in 1965, followed by Jupiter in 1966. 1973, Mercury didn't appear until 1974. This arrangement may already appear a little strange. Odd. The distance at which the Earth and Mercury is 77 million kilometers away. In actuality, it is the planet that is closest to us average. The distance at which the Earth and Jupiter is 588 million kilometers from Earth, or nearly 8 times. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. 2 further trips to Jupiter were made in 1974. 1979, 1992, 1995, 2000, and 2007 were among the years. There were several missions sent to Saturn, from comets and asteroids to Uranus and Neptune. Mercury received nothing for 30 years. Is this a result of it being rejected as being boring? Have we found everything there is to know relating to that long, initial mission? No. The initial mission was a flyby and only involved mapping 40 to 45% of Mercury's surface. Actually, Mercury is the main culprit. It is one of the hardest worlds to navigate. Somewhere in our solar system. Why? Well, a furnace is where Mercury is found. Because of how close it is to the Sun, its surface highs and temperature surpass 430 degrees Celsius, so any visiting it would require an extremely skilled probe. Resistant to heat. However, due to the Earth's close proximity to the Sun, any probe sent there will move faster, increasing due to the powerful gravitational pull pulling away from our star while utilizing rocket fuel that would be equivalent to swimming through rapids. The gravity of the Sun had to be fought as well. Much fuel for a spacecraft of the Discovery class to transport, sufficiently reducing spaceship speed, it appeared to be caught up in Mercury's orbit. Impossible. But after the Messenger mission, everything was different. You're watching Alex McColgan, and I'm Alex. Astrum. Additionally, today's lesson will focus on humankind's the only thing to do is to stick a probe into orbit a planet that is among the most difficult to reach through the solar system. When it comes to restrictions, weight reaches spaceship. The larger the rocket used, the heavier the vehicle for it to be removed from Earth's orbit, and the everything increases in cost. Everything is kept as light as possible by scientists. As much as you can to cut this expense. Since fuel consumes limited weight allotments, it could be used for scientific equipment. Science makes an effort to just take what is essential to assist them in finishing their quest. Nevertheless, for roughly 30 years, researchers cannot think of a way to adequately fuel a probe. To slow it down enough to go inside Mercury's, particularly if they want scientific equipment also on board. In light of Mariner 10's successful flyby, Mercury missions between 1974 and 1975, Mercury the exploration was suspended. However, a specialist in orbital mechanics by the name of Chen Yin saw there was a solution. Of launching a spacecraft into Mercury orbit, this didn't require modern technologies. Instead, he had developed a certain route. The solar system might be circled by an orbiter, so causing it to become sluggish enough to enter Mercury's orbit after only a few minor path adjustments. Instead of flying directly to Mercury, the orbiter would have to travel farther. How many? A craft would, in Chen Yin's paradigm, about 15 times around the Sun, passing through Earth, Venus, and Mercury, all occur 3 times, before eventually settling down to enter on the 4th pass of its orbit. these numerous planetary flybys would be necessary. By scanning the atmospheres of the planets, a crucial speed reduction from atmosphere due to drag and the planet's gravitational pull, the total path would travel a whopping 7.9 miles, billion kilometers, which would take 6.5 years. The results of Qianhuan were not immediately picked up, but NASA started to take over in 1998. A fascination with the concept, and after viewing the route's viability, they started the 2004 Messenger investigation. The Mercury surface space environment, also known as Messenger, only 1.8 meters for the geochemistry and ranging probe, 1,100 kilograms and 1.3 meters long and wide. For conventional NASA, this is compact and lightweight. Mission: Juno is 20 meters long as a comparison. The Messenger was fitted with a strong thruster, a ceramic barrier to insulate it from the heat, 2 solar panels, the sun, and a full array of scientific tools for measuring and picturing Mercator data. Scientists intended to benefit from this. The chance to learn everything they could about Mercury's chemical composition, its surface, geological past, and magnetic field and its essence, among other things. Messenger produced a lot during its first year in space. A single orbit around the Sun, then reuniting back up with Earth. This offered researchers the chance to evaluate its apparatus on a recognized astronomical body, to ensure there were no mistakes and to make any necessary alterations. Messenger captured images of the planet Earth and the Moon, as well as testing its other apparatus to measure the magnetosphere and environment around us. Thankfully, everything was operating flawlessly. Messenger started to move more toward the Sun, utilized a clever technique to assist in as it moves closer to the Sun. It caught solar energy using its solar panels. Radiation, which might cause ship sails to catch wind. Actually, solar radiation striking a target pushes it just a little bit. Despite the fact that this power is minuscule, Messenger's it definitely built up since the journey was so long. One strategy for maximizing this phenomena was Messenger's methods for conserving propellant and slowed down naturally. The following significant event in Messenger's voyage began in 2006, the year it performed Venus's flyby. Sadly, this time occurred at a bad time for scientists. A period of time when Venus was exactly on the Messenger was on the earthward side of the Sunday was not speaking. On the radio, it did get some images of the planet and later sent, but otherwise made no more moves. Science. But it again passed Venus in 2007. Another spacecraft was orbiting at the time. Venus Express from the ESA. The Venus Express and Messenger seized the chance to collaborate and execute the first ever concurrent observations of the particle and the field, the features of the planet. Mercury, though, was the main attraction after that. Mercury underwent Messenger's first flyby. On January 14, 2008, everything was going smoothly. The second flyby had the same characteristics. But something happened during the third flyby in 2009 went awry. Messenger entered the intended safe mode to safeguard equipment on the craft in the event of a mistake. What a letdown after traveling so far to simply the mission could possibly fail while among the last steps. For what needed to be done, Messenger remained in safe mode. 7 hours of stress for everyone involved. Scientists consider that Messenger had to traverse Mercury's during this pass. There was no shadow, thus it had to rely for 18 minutes on its batteries. Something wasn't set up properly in the software component for managing electricity. Thankfully, Messenger's PC rebooted when the battery was fully charged by the solar panels, and it was able to carry out its objective, swinging one more around the Sun before eventually departing for Mercury's orbit on the March 11, 2011. An elliptical orbit was established by Messenger around Mercury, varying between 200 miles away km and up to 15,000 kilometers distant. Because Mercury behaves somewhat like a massive sun mirror reflecting heat into space. It was too hot to continue too close to Mercury. Even with its heat protection for Messenger, which was primarily created to shield it from the sun 7 times brighter than it is by Mercury on Earth, therefore every 12 moving farther away hours gave it time to calm down. The following 4 years Messenger was in Mercury's exceeding scientists' expectations, and expectations they had for the mission was intended to only last for a short time, 1 year. Scientists had hoped that Messenger would succeed before launch, would shoot at least 1,000 pictures throughout its existence. But Messenger captured more than 200,000 pictures, providing a thorough map of Mercury's surface, full color and high resolution, as well as taking pictures of other planets and close comets. On December 25, 2014, Messenger's fuel, so meticulously saved till then, was at last about to expire. Messenger was orbiting a small planet at this time, 25 kilometers from the planet's surface. The thrusters were fired once again by the scientists, extending its orbit as far as it could. However, Messenger collapsed on April 30, 2015, into Mercury's surface. Over a decade had passed since the start of the adventure, and having traveled countless billions of miles, the journey of Messenger was over. Now, if this mission's scientific results would be something that you'd be enthusiastic about for a future video, kindly inform me by leave a remark or a like. It's definitely a topic that interests me. I'm hoping you'll agree, too. Additionally, Mercury's exploits don't finishing with Messenger. The ESA-JAXA cooperative bepicolumbo launch in 2025. When mission reaches Mercury, it will assume control. The controls from NASA Mercury or Bust platform, which discusses in depth what makes this mission what ESA/JAXA intend to accomplish, is unique. For a while, they assert that the bepicolumbo satellite is among the trickiest scientific endeavors. A single spacecraft that will be divided into 2 ships after reaching Mercury is absolutely something to learn about. More information.